Hi, I found eighth grade. I hope that you guys have already gotten the hang of listening to these lecture slides and videos with my voice over it. I hope that it's been helpful and I hope that it continues to help you. Now, today we're going to be continuing on the chemical formulas and bonds and the type of chemical bonding that occurs between atoms. We are going to first go over this first type of bond called covalent bonds, and in later lessons we'll go over ionic bonds and metallic bonds, but this lesson is specifically on covalent bonds. But before we get into that, if you've ever baked cupcakes before, you have to combine the egg, the mix, the milk, the flour, the sugar, and all the different stuff. Even though each ingredient is very different, once you mix it all together and bake it, you create a totally different product. In that same way, when you take elements that are completely different, each element is very different, and you combine them together, they form very, very different and a new product or compound. So, like I said, in that same way, you combine the ingredients or the elements to make a compound or cupcake. So, you can see here that you combine the hydrogen and the oxygen that are very different on their own, and it creates this liquid called water, H2O. So the elements need to bond. We talked about chemical bonds in the last lesson, but they need to bond in order to create compounds. Now, the most common type of a bond is called the covalent bond. And the important thing to know, as it's highlighted, is that a covalent bond is where two atoms share, I'm going to say that again, they are sharing one or more pairs of these valence electrons. So the chemical bond that is formed when a covalent bond is forming is this sharing of these valence electrons. And you can see it right here where the carbon is sharing the valence electrons with the hydrogen. The noble gas arrangement is the most stable arrangement there is. And we learned that that's what all the other elements want to be like. They want to be like the noble gas electrons. And this level of stability that these atoms want to reach is called the noble gas electron arrangement. And that is when they have that full set of 8 valence electrons where no valence electron goes without a pair. All the atoms want to be like them. They want to be stable. They want to be like the noble gases. Now, there can be single, double, and triple covalent bonds. A single covalent bond is when the two atoms share only one pair of valence electrons. A double is when two atoms share two bonds or pairs of valence electrons. And a triple is when two atoms share 3 bonds or pairs of valence electrons. And the most common example of this is a single bond is hydrogen. It's when 2 hydrogen atoms are sharing 1 bond, as you can see right here. And then a double is when 2 of the oxygen atoms are sharing 2 bonds, as you can see right here. That pair right here is symbolized at the top as a line, and the second pair at the bottom shows that double line. And that triple bond example is of nitrogen, where 2 nitrogen atoms are sharing 3 bonds or 3 pairs, 1, 2, 3 of valence electrons. And here's another little visual representation right there. Now, covalent compounds. Covalent bonding creates molecules. So molecules are groups of atoms that are held together by covalent bonding specifically, and these molecules act as an independent unit. Like the example that's shown here, sugar is going to be a molecule, which is a result of covalent bonding. And the chemical formula for that is C6H12O6. There's 6 carbons, 12 hydrogens, and 6 oxygens. And you can see these nice little models of glucose right there. And once again, molecules are held together by covalent bonds. Now, there are 2 types of molecules out there. There are polar molecules and nonpolar molecules. And the most important thing to note is that like dissolves like. That bolded all in caps statement right there is so important. When you try to mix water, a polar molecule with oil, a nonpolar molecule, does it mix? No, it doesn't, because polar cannot dissolve into nonpolar and nonpolar cannot dissolve into polar. Polar molecules must dissolve in polar compounds and nonpolar molecules must dissolve in nonpolar compounds. So like dissolves like. Always remember that statement. Like dissolves like. An example of a polar molecule is water, and an example of a nonpolar molecule is oil. Now, a chemical formula, like I had mentioned in the glucose a couple slides before, is a group of chemical symbols and numbers that represent the elements. So the chemical symbol is going to be the element. That's why they are both in green. The chemical symbol is the element. And the numbers that are shown in this chemical formula, as you can see here, is going to be the number of atoms of each element. So when you see something like this, C6H12O6 or H2O or NH4 or NH3, if you see CO2, any type of chemical formula, you know that that chemical symbol is going to be the element. And we see it on the periodic table when we see carbon, when we see hydrogen or oxygen. And the number that follows with it is going to be the number of atoms of that element. Now, a couple examples of molecular models that your book gives us. The first one, we actually practice this in class, are the electron dot diagrams. And this type of diagram shows the atoms and their valence electrons. So the atom, oxygen, and carbon, as well as their valence electrons. And as you can see here, there's double bonds, double bonds. And another example of a molecular model that your book shows us is the structural formula. The structural formula shows the atoms and the lines, the double bonds, and that line represents one share of paired electrons. Another example of a molecular model is the ball and stick model. And here the sticks are actually bent a little, and it's to show the types of bond angles happening in this specific type of molecule. And lastly is the space filling model, and these spheres obviously represent the atoms, and it also shows this 3D arrangement of the atoms. So this lecture was fairly short, but this is the covalent bond lecture. We will be learning about different other types of bonds like ionic bonds and metallic bonds, but remember that covalent bonds always share the pairs of valence electrons.